All right, ladies and gentlemen, and the last thing we're going to talk about for today is apparent weight. So with apparent weight, right, we've already talked about weight. What is weight? How do we determine weight? That's by our force due to gravity, right? That's our mass times our acceleration due to gravity, how much we're being pulled down. Well, with apparent weight, it is you feel your weight not because of gravity pulling down, but because of the normal force pushing back up on you. That's what makes us feel like our actual weight, the normal force. That force that is pushing back up onto us. Now, the normal force again is weight when on a flat surface in equilibrium, right? At rest or constant velocity, right? When you're on a flat surface in equilibrium, you're either at rest or constant velocity. Remember, normal force pushes up at a 90-degree angle, right? Perpendicular to the surface. So, guys, this right here, there's only a few things that we need to know. It's very straightforward and specific. So, there's different cases, right? We're going to be dealing with elevators, right? And you may see one elevator question on the Regents. And I'm going to tell you exactly what you need to know. Well, when you're at rest, you feel your actual weight. So I'm going to come down here and we're going to write on this part. So at rest, you know that Fn, the normal force, is going to be equal to Fg, right? So you feel your weight. Right? You feel your actual weight. At 2, so now we're going to accelerate upwards. Well, at this case, when we're accelerating upwards, Fn, that normal force, is going to be greater than Fg. That normal force is greater than Fg because we're pushing up, right? And when that happens, you feel heavy. Now let's talk about accelerating downward. This is now when Fg is greater than Fn. And in this case, you feel light. You don't feel as heavy. But you feel lighter when you go down in an elevator. And then number 4, when you're traveling at a constant speed, again, Fn equals Fg, so we're at equilibrium. And now we're back to just feeling your weight. So ladies and gentlemen, that is all we need to know with apparent weight, right? When you're at rest or you're at constant speed, we're at equilibrium, which will then equal out to that we feel our actual weight, right? When you're at rest or you're at constant speed, there is no acceleration. That's why we are at equilibrium. When you accelerate upwards, we now experience a higher normal force than gravitational force, which will make you feel heavy. And then when you're accelerating downward, the gravitational force will be greater than the normal force, which will make you feel lighter. All right, ladies and gentlemen, that is it for today. Watch the 3 videos I've posted and complete those 2 worksheets. We'll talk to you tomorrow.